Welcome to Study Loop.
All right, we're going to start this problem with what we know. We know that we are dealing with a shipment of 24 smartphones. We know of those 24 smartphones that 6 are defective. Which then results in 18 that are not defective. We know that we are going to inspect 3 of them. And we're going to ship the shipment back if we find too many that are defective. So let's look at our probability distribution. So we are focusing on defective. So that means we might look at 3 and find 0 to be defective, or 1, or 2, or 3. And that's all the possible outcomes. So that's our entire probability distribution. And as long as we have a complete probability distribution, we know that the sum of all the p of x's will equal 1. So now we are going to ship the whole shipment back if when we check 3, we find at least 1 to be defective. So in this case, x is going to be at least 1. Which is the same thing as saying it could be 1, or it could be 2, or it could be 3. So therefore, we are focused on the sum of these probabilities. Now, once we select a phone and we check to see if it's defective or not, we're not going to replace it. So therefore, we are sampling without replacement. And if we sample without replacement, then we are talking about a hypergeometric distribution. And if it's a hypergeometric distribution, we have a formula that we can utilize. And the formula says the combination of A items taken x at a time multiplied by the combination of B items taken n minus x at a time divided by the combination of A plus B items taken n at a time, where in this case A represents the favorable count, and since we defined favorable as being defective, then we know A is going to be 6. And the B represents the unfavorable, so in our instance, B is going to be the 18. So we have all the parts that we need to utilize this formula. We have an A, we have a B, we have an N, and in this case we have 3 values of x. So that means we can use this formula 3 different times. Or if instead of using the formula 3 different times to find the probabilities for 1, 2, 3, let's use it just once to find the probability of 0. And then once we know the probability of 0, we can do 1 take away the probability of 0 to find the sum of 1, 2, and 3. So we're going to apply the formula for 0. So we're going to have 6 items taken 0 at a time times 18 items taken n minus 0 at a time, all over 6 plus 18 items, taken 3 at a time. If we clean that up a little bit, we would get 6 items taken 0 at a time, multiplied by 18 items taken 3 at a time, all over 24 items taken 3 at a time. And if we use our calculator, we're going to find that the probability of 0 defective phones to be 102 divided by 253. Let's try that again. Kind of didn't. So 102 divided by 253. So now all we have left is to do the 1 minus, and we will find the probability of at least 1. So the probability of at least 1 equals 1 minus the probability of 0, or 1 minus 102 over 253. So our probability ends up being 151 over 253, or we can transition that into a fraction, or sorry, into a decimal, and our probability would end up being 0.5968.